Okay, this is the rest of lesson 5-1. So 5-1 day 2, we're going to go over some terminology first. So the first thing is polynomials. A polynomial is a combination of monomial terms separated by the plus or minus, and they cannot contain the following. So a monomial is just one term, like the term 3x. It's a monomial. When you start adding things to it, like that, that's when it becomes a polynomial. Okay, so it's a polynomial is a combination of individual monomial terms. So that's a monomial, and that's a monomial. When you start combining them with plus and minus, that's when it becomes a polynomial. They cannot contain any of the following things. So the first thing is variables can raise to a negative or fractional exponent. So this is what it cannot contain. Let me highlight that word not. So if you see an expression that has a negative or a fractional exponent, it is not a monomial. You cannot have variables in the denominator. Okay. So if you have like 1 over x, x is in the denominator, that's not a monomial. You cannot have variables underneath the radical sign like this right here. Like, so if you had a radical like this and a variable underneath it, that's not a monomial. And then you can't have any special features, which you don't know many of these yet. You know the absolute value. So if you had the absolute value of x, that's not a polynomial. If you had any trig functions, which you don't know those yet, and if you had any logarithms, which again, you don't know those. So if you had any of those, then it is not a polynomial. So I have some examples here. Before we get into that, Delta Math is going to ask you if things are a polynomial, and then if they are, they're going to ask you to name what type of polynomial they are. So a monomial is one term. Just like I showed you on the previous page. A binomial is two terms. A trinomial is three terms. These are all words that you should know, but just it's a good refresher. So if it is a polynomial, the Delta Math is going to ask you what kind it is as well. So the degree of a polynomial, it depends if there's one or two variables in it. So the example 2 says determine whether each expression is a polynomial. If it is, then state the degree. And we are also going to state what kind of polynomial it is. So this first one, I have 1/4 x to the 4th, y to the 3rd, minus 8x to the 5th. So first of all, I have to determine if it's a polynomial. And if you go back to the list on the previous page, or if you flip your notepad over, I don't have any negative or fractional exponent. Okay, so my exponents are these right here. None of those are negatives and none of those are fractions. So that's good. I don't have any variables in the denominator. The only thing I have in the denominator is a 4. So that's good. I don't have any radical signs and I don't have any special features. So this is a polynomial. So it's yes. And then tell me the degree of it. So it first of all, you have to determine, do you have two variables or one variable here? And we have two variables. We have x's and y's, okay? So when you have x's and y's like this, what you're going to do is take the sum of each. Let me underline these first. So we have two terms here, okay? So it is a binomial because there's two terms. So if you want to go ahead and put that in there, we could do that as well. And then I need the degree of it. So what you're going to do is take this first term, 1/4 x to the 4th, y to the 3rd, and you're going to add their exponents. So I have a 4 and a 3, so that's a 7 when you add those together. And then in the other term, I just have 8x to the 5th, so that that exponent is a 5. The degree is the largest of those two numbers that we just found. So it'd be a 7. So the degree of this is a 7. Okay, so again, to find the degree, you take each individual term. So 1/4 x to the 4th y to the 3rd was one term, and then 8x to the 5th is another term. And if you have more than one variable in a term, so that first one we had an x to the 4th and a y to the 3rd, you had to add their exponents. In the next one, 8x to the 5th, you just had one term, one variable, so that that exponent is a 5, and then the degree of it is the largest of those numbers there. So the next one, the square root of x plus 4, the square root of x plus 4. So first of all, determine if it's a polynomial. I don't have any variables raised to a negative or a fractional exponent. I don't have any exponents, so it's all understood to be an exponent of 1. I don't have any variables in the denominator, but I do have a variable underneath a radical sign right there. So this is not a polynomial. If it's not a polynomial, I don't need the degree and I don't need to know what type it is. Next one, x to the negative 3 plus 2x to the negative 2 plus 6. X to the negative 3 plus 2x to the negative 2 plus 6. So again, run through the list. Do you have any variables raised to a negative exponent? Yes, I do, right here. I have there and there, so therefore this is not a polynomial. Okay. Now I'm going to give you a couple other examples. Actually, just one other example. D, just add right here. Negative x squared plus x to the 4th square root 3 minus 2r to the 5th. Negative, I'm sorry, I don't know why let me erase that r, that should be an x. I copied that from Delta Math, or somewhere, I don't even remember where I copied it from. And I wanted them all to be x's instead of the variable r. So negative x squared plus x to the 4th square root 3 minus 2x to the 5th. Okay, so first of all, go back to your list. Variables raised to a negative or fractional exponent. I do not have any of those. All my exponents are normal, so we are good. I do not have any variables in a denominator. I don't have any variables underneath the radical sign. I do have a radical, but it's not a variable, so I'm good. And I do not have any special features, so this is a polynomial. Okay. It has how many terms? So let me underline them for you. 1, 2, 3. So basically, anywhere you start to see a plus or minus sign, that starts a new term. So I have 3 terms. 3 terms is a trinomial. Now I need to know the degree of it. Okay, so if you notice here, there's only one variable. So here you just look for the highest degree. Back on A, I had 2 variables, so I had to take the sum, that 4 plus 3 back on A. But here I only have 1 variable, so the degree is just the largest exponent, which is 5. So the degree is 5. Okay, now we are going to do some really easy stuff, which you guys already know, so I might kind of breeze through this. If I go too fast, just rewind the video, or you can actually put it in slow-mo or whatever you want to do, okay? So I have, go ahead and fill in your notes, 2x squared plus 3x minus 1. So when you see parentheses, you always want to look to see if there's anything you need to distribute. In this first set of parentheses, when I highlight it there, you'll notice there's nothing in front of it, so technically I can just drop the parentheses. But the second set of parentheses, I do have something I need to distribute. I need to distribute that negative. So I'm going to have to distribute that negative. It's like a negative 1. If you want to put a 1 there, you can. So that would be minus 2x squared minus 3x plus 1. And then you just combine like terms. So start with your highest exponent first. So my highest exponent is 4x squared minus 2x squared would be 2x squared. Then go to the next highest exponent, which would be just your x's. Negative 5x minus 3x. Negative 5 minus 3 is minus 8x. And then your next, let's see, just be your constants then after that. And that would be 6 plus 1 is 7. So distribute your negative, if there is one, your minus sign, and then just combine like terms. The only difference is maybe if you haven't done this before, which I'm sure you have though, is that you always start with your highest exponent, so start with your squared and then work your way down. Next one, 6x squared minus 7x plus 8, and then add in your notes, negative 4x squared plus 9x minus 5 in parentheses. Again, look in front of the parentheses. There's nothing to distribute there, so I'm just going to drop the parentheses. And look at your next set of parentheses. There's nothing I need to distribute there because it's a plus sign, so I'm just going to drop my parentheses. And then I'm going to combine like terms, starting with the highest exponent first. I have 6x squared minus 4x squared. That'd be 2x squared. Next, I have negative 7x plus 9. That would be a positive 2x. Negative 7 plus 9. And then the last one, I have 8 minus 5. 8 minus 5 is a positive 3. So your answer is 2x squared plus 2x plus 3. So you're just adding like terms. So that is stating the degree of a polynomial. We added and subtracted like terms. The next thing we're going to do is multiply like terms. So go ahead and fill out your notes. 3x times parentheses 2x squared minus 4x plus 6. This is just a distributive property. We're distributing 3x to everything inside the parentheses, and there's 3 things inside. So 3x times 2x squared, you're going to have to remember your properties of exponents. 3x times 2x squared is 6x to the third, because you have an x to the 1 times x squared. That's when you add their exponents. 3x times negative 4x would be minus 12x squared. 3x times negative 4x. And 3x times 6 would be plus 18x. Okay? So again, you've done this before probably. Just been a while, so this is just a good refresher. And we're using those properties of exponents that we learned earlier. Multiplying polynomials. We have n squared plus 4n minus 6 times n plus 2. So this is the box method, okay? You have a 3, this is 3 terms, 1, 2, 3 by 2 terms. So you need a 3 by 2 box. It does not matter how you do the 3 by 2 box. I do the 3 across the top and the 2 down the side, but it does not matter the order. So make your box and then start filling in the boxes. N times n squared would be n to the third. 4n times n would be 4n squared. N times negative 6 would be negative 6n. That's your first row. 2 times n squared would be 2n squared. 2 times 4n is 8n. And 2 times negative 6 is negative 12. Again, it doesn't matter how you do your box. I did the 3 across the top and the 2 down. You could have done the 3 down and 2 across the top. And then what you want to do is start with your highest exponent for your answer and then work your way down. So I have an n to the third, and I don't have any other n to the third, so n to the third comes first. Let's do our next term. I have 2n squared and 4n squared. They're both positive, so that'd be plus 6n squared. Next one, I have an 8n minus 6. That's 8 minus 6, so that'd be a positive 2n. And then the last one I have is just the minus 12. There's nothing else to combine with that, so minus 12. So again, just make your box. I believe I selected the problems in Delta Math, if I remember right. That you make the box, like it asks you how many rows, how many columns, or how big do you want the box to be, basically. And then you get to put wherever you want the trinomial, and then you just fill in your boxes. I believe that's what I did. Next one, I have 2x minus 4 parentheses squared. 2x minus 4 parentheses squared. A common mistake made is people just square the first term and square the last term and call it good, and that is wrong. Okay, don't do that. 2x minus 4 squared means 2x minus 4 times 2x minus 4. Squared means times itself, so it means 2x minus 4 times itself. Now you have a binomial times a binomial, so that's a 2 by 2 box, and then fill it in and start multiplying, okay? And you'll see the difference in the answer here in a second. So again, don't just square the first term and the last term and call it good. That's not correct. You'll see how similar the answer is, but it's not quite. So I get 4x squared minus 8x and plus 16. Start with your highest exponent first. 4x squared, there's nothing else to combine with that. So that looks kind of like my answer up at the top. And then I have negative 8x and negative 8x. Negative 8 minus 8 is negative 16x. Okay, I didn't have that in there. And my answer up at the top in red. And then my other one is plus 16. So plus 16. So I did have a plus 16 now. So you'll notice if you did the mistake that I commonly see made, you're going to miss that middle term, negative 16x. Okay? So make sure you don't make that mistake. Okay, the last one's going to be some extra credit here, so I want you to go ahead and fill in on your notes. Okay, after you get it filled in, you'll notice we have 3 parentheses here. The box method, though, you can only do 2 at a time. So what you're going to do is you're going to do the box method for these 2, get that new answer, and then you're going to multiply that answer, whatever it may be, times this one using the box method. Okay, so multiply the first 2 by using the box method, and then take that answer that you get for the first 2 multiplied by the next one using the box method. Now, there's 2 variables in here. There's x's and y's. So when you multiply, say you have to multiply, I'm just going to give you a little hint here. Say you have to multiply x times 3y. Make sure you do the answer alphabetical. So it'd be 3xy, not 3yx. Okay? So when you have to multiply multiple variables, make sure you write your answer as alphabetical. Okay? And that'll make combining like terms a little bit easier. But I'm going to make this one extra credit. If you do this problem, you don't have to do this problem, okay? But if you do, show me all the work using the box method, not doing what Photomath tells you to do, because Photomath's not correct, or Mathway or any other website out there. Just do the box method. Even if you got it wrong, I'll give you extra credit. And take a picture of it and email it to me. And that completes this lesson, so just go ahead and get to work on your Delta Math.